Hello everyone. Welcome to today's session on circles. In the circles chapter, we will cover the properties of tangents. Okay. So we learned what a tangent is. Now let's look at what are the properties of tangents. So what is a tangent? A tangent is a line which touches the circle at one point. So this is the circle, and let's say at one point. So this is the tangent. Tangent xy that's touching at the point P. Now, what are the properties of tangent? So how many tangents we can draw to a circle? We learn there are infinite tangents we can draw. Now, how many we can draw? Infinite number of tangents. So let's look at what happens if I have a circle here and I have a point P. I have point P inside the circle. So can I draw tangent from a point inside the circle? Inside the circles, if I draw a line, right, passing through P, that is your secant, but that's not a tangent. So we cannot draw tangents from a point inside the circle. So no tangent. So we cannot draw a tangent from a point inside the circle. So can we draw a tangent from a point on the circle? That is yes, right? So we can draw. How many tangents we can draw? One tangent we can draw from a point on the circle. What happens if the point is outside the circle, somewhere here, right? If the point P is somewhere here, how many tangents that we can draw? So if I draw here, I would say we can draw two tangents. One from here, and similarly another from there, right? So from a point outside the circle, we can draw two tangents. So listen carefully. So how many tangents we can draw from a point inside the circle? No tangents. So we cannot draw any tangent from a point inside the circle. It's only a secant we can draw. Okay. So how many tangents we can draw from a point on the circle is one tangent. So how many tangents we can draw from a point outside the circle? So if it is outside the circle, how many? We can draw two tangents. Outside the circles, we can draw two tangents. And we also learn if this is the center O of the circle, then the line joining the center and this point, let's say if this point is, let's say Q. If this point is Q and this point is R. 1 minute, guys. If this point is R, then this angle is right angle, and similarly, this angle with the tangent is also right angle. That's what the property we learned. So the properties of tangents are inside the circle, no tangents. On the circle, from a point, we can draw one tangent. Outside of the circle, if we have a point, we can draw two tangents. And that tangent touches the circle at 2 points. And that point and the center of the circle will make 90 degrees. Okay. All right. So there is another theorem here. The lengths of tangents drawn from an external point to a circle are equal. Okay, let's see. The lengths of tangent. So we just saw how many tangents we can draw from an external point. So that is two tangents. So this theorem is saying the length of tangents drawn from an external point to a circle are equal. Okay, let's see how that is. Right. So let's say this is a circle. And let's say this is the center O. Now I have an external point. Let's say I'll take uh, on the same axis. Okay. I'm drawing with free hand, so it can be little, right? Okay. So I have a point A I have a point A, which is OA is the distance between the center of the circle and this point A, right? So which is external to the circle. And from this point, I can draw how many circles? I can draw, sorry, how many tangents? I can draw two. Let's say this is a tangent that is touching at point P. And similarly, from A to the other side, I can draw, uh, so I can draw another tangent, right? Let's say that is touching at R. Now we know that the line joining OP and OR will make 90 degrees with the tangent. That's the first theorem, right? The point of intersection of the tangent and the line drawn from the center to that point, that's the radius, makes at an angle 90 degrees, right? So this is what we learned so far. Now, from this theorem, what they are saying is the length of the tangent. What is the length of the tangent? PA. So, length of tangent, that is PA is equal to PB. That's what they're saying. The length of the tangent is PA and, sorry, what is PA? Yeah, PA and RA. Where did we get PB? PA equal to RA, right? R is the other point, right? So RA and PA, these two are equal as per this theorem. Let's see how. So if you closely look at this, right? So if you closely look at this, OPA is a right angle triangle, and similarly ORA is also right angle triangle. So I can say delta OPA, delta OPA and delta ORA. So these two are right angle triangles, right? So if it is right angle triangle, what I can say, and also these two are right angle triangles. So we can apply Pythagoras theorem, right? If these are right angle triangles, we can obviously apply Pythagoras theorem. That's one thing. And the other thing is, I can also say OP is equal to OR, that is nothing but the radius of the circle, correct? OP is the radius, OR is the radius. So those two are equal. Good. And what else is equal here? OA is a common side for both. So OA for this triangle is common, right, for both the triangles. So what is OA? OA is our hypotenuse in the right angle triangle. You agree? So if this is right angle, the side opposite to right angle is this. So this is our hypotenuse. So OA is hypotenuse, which is common to both the triangles. That means here two sides are equal, right? Two sides are equal. OP, OR are equal. OA, OA is a common side. So can I say this delta OPA is similar to delta ORA? Can I say that? So these two are similar triangles. So if these two are similar triangles, then the ratio of the proportionate sides is equal, right? The property of similar triangles is the ratio of. So what is the ratio of the respective sides? Like OP by OR equal to OA by OA. The hypotenuse is same both. And PA by RA, right? The properties of similar triangles. As per the properties of similar triangles, what we can say? We can say the ratio of the respective sides. So here, hypotenuse by hypotenuse, opposite side by opposite side. and adjacent side by adjacent side. These three ratios are equal. That's the property of a similar triangle. So in this case, if OP by OR is 1, right? Both are equal. And OA by OA is 1. So can I write this as PA by RA equal to 1? And then PA equal to RA. What is PA and RA? The lengths of the tangents. Therefore, we can say the length of the tangents drawn from an external point is both to a circle are equal. Okay, that's what the theorem is. So how we proved this theorem? So we draw the circle and we took the external point as A, and then we draw the tangents to that. The tangents are P touches the circle on P and R. Then what we observed is OP equal to OR, that is the radius. And similarly, OA is a common side. So when two sides are common, then we can say, I mean, two sides are equal, then we can say these are similar triangles. So the property of similar triangles is the ratio of the respective sides are equal. So if we do that, then I am getting like PA by RA is 1. So then PA equal to RA. What is PA? The length of the tangent, which is touching at point P, and RA is the length of the tangent which is touching at point R. So PA equal to RA, that is, hence we can say that the length of the tangents drawn from an external point to a circle are equal. Okay, that's the theorem that if they ask. Okay. So now two properties that we learned, right? One is the tangent makes an angle 90 degrees with the radius, and the tangents drawn from an external point, we can draw two tangents, and those two tangents form two right angle triangles. They obey the what is that Pythagoras theorem. And we also learned that the length of the tangents that are drawn from an external point are equal. Okay. Okay. So based on that, let's see if we can solve these problems, right? So from a point Q, the length of tangent to a circle is 24 centimeter and the distance of Q from the center is 25, the radius of the circle. Okay, so here this type of problems can be asked. So the first problem is there is a circle. Okay, from a point Q, the length of the tangent. So somewhere there is a point Q, somewhere here. Okay, so the length of the tangent. So if a tangent is drawn here, right? So the length of the tangent is given as 24 centimeters. Okay. And the distance of point Q from the center, let's say O is the center. Now, this distance is given. That distance is 25 centimeter. Now, asking us to find the radius. So this is the radius, right? This is R. Let's say this is point P. We know that the radius makes an angle 90 degree with the tangent. So we can say OPQ is a right angle triangle, right? So if OPQ is a right angle triangle, can I write that the hypotenuse is OQ square equal to OP square plus PQ square, right? I know OQ, that is hypotenuse 25. I know PQ, length of the tangent, that is 24. And I also know OP, which is radius, which we need to find. Okay, so let's substitute the values. So 25 square equal to R square plus PQ is 24 square. So R square becomes 25 square minus 24 square. So what is 25 square? 625 minus 24 square is, I think, 576. So I get 49. So R square is 49. So R I can say 7 centimeters. Okay. So that's how we got the radius. So these type of problems they'll give. So it is very simple. We know that the tangent and the radius makes 90 degrees. So that forms a right angle triangle. Just apply Pythagoras. So if you apply Pythagoras, whatever the side you don't know, you can find. Sometimes they'll give radius. Sometimes they'll ask you to find the length of the tangent. Sometimes they give the radius and length of the tangent, and they'll ask you to find the how far that point is from the center. Okay. So we just need to remember how to draw this triangle and how to apply which is hypotenuse. Always the line joining the center and the point is hypotenuse because this is 90 degrees. The angle opposite to 90 degrees is hypotenuse. Okay, that's what you need to remember. Okay, now from this, from the figure here, if TP and TQ are the two tangents, yeah, TP and TQ are two tangents to a circle with center as O. So that POQ, so at the center it's making an angle 110 degrees. Then what is the angle PTQ? Okay, so this angle is being asked. So this is like a quadrilateral, right? So four sides is a quadrilateral. And we know this is 90 degrees. And this is also 90 degrees. The tangent makes with the center 90 degrees. And this is 90 degrees. So this is, if this is 90 and 90, this is 180. If this is 110, it should be 80 degrees. Oh, no, 70 degrees, right? This also should be 180. So that means this is 70 degrees. So the total angles, the sum of all the four angles in a quadrilateral is 360 degrees. So this is 90, 90, 180. So these two should be 180. So if this is 110, this should be 70, right? So this is 70. So just applying the knowledge that we have learned. So what knowledge we applied here? This is 90 degrees. If we know three angles, the other angle we can find in a quadrilateral. Okay. Or you just remember as a thumb rule, if this is 120, this is 70. Both the angles at the center at the point should be 180 degrees because the other two is anyways 180 degrees at the tangents. Okay. That you can remember. If it is 100, this is 80, right? Like that. Okay. Let's see the next one. If tangents PA and PB from a point P to a circle with center O are inclined to each other at an angle 80, then what is POA? Same problem, but yeah, let's draw the diagram. Then you can answer it easily. Okay, we have a circle. They are saying if tangents PA and PB. Okay, so let's say this is the center O and the length of the tangents are PA and PB. So P is the point, external point. This is touching at 2 points. That is A and it's B. This is basically touching here. Okay. Now are inclined each other at an angle 80. So the tangents are making an angle 80 degrees. Then POA. POA. So this angle is being asked. Okay, let's see. So from this problem, if this is 70, this is 110. If this is 80, what is this angle? Right? 100. Now what is asked? Angle POA. Angle POA. That means, let's just join this line. This angle. This angle is what? Half of this total angle, right? So angle POA is also equal to angle POB, which is 100 by 2. Half of the angle. So that means 50 degrees. You understood? So this angle they are asking. The total angle is 100 because if this is 80, that angle is 100, but only half of the angle is asked. So it is 50 degrees. Okay. So these type of problems can be asked. Next. The length of a tangent from a point A at distance 5 centimeter from the center of the circle is 4 centimeter. So basically the length of the point is given and the length of the tangent is given. We need to find the radius. Yeah, again, simple. Just draw a circle. Okay. Let's say this is at O and there is a point here. Join this line. This is the point is A, right? From a point A at a distance 5 centimeters. So OA is given. OA is 5 centimeters and the length of the tangent from point A at a distance 5 centimeters from the center of the circle is 4 centimeters. So that means the tangent length is 4 centimeters. Okay, let's say the tangent is touching at point P, then this length is 4 centimeters. So what is that? AP. And also another hint I will give you. If you get confused between whether it is 5 centimeters or 4 centimeters, always hypotenuse is larger side in a right angle triangle. So which is hypotenuse? This one. This side should be the bigger one. Just a hint I'm giving you. Okay. And we know this is right angle. So this is 5 centimeters. and R we need to find, radius we need to find. Use Pythagoras. So from this triangle OAP, what is hypotenuse? OA square equal to OP square plus PA square, right? So what is OA square? 5 square equal to OP is R, so R square plus PA is 4, so 4 square. So what is R square? 5 square minus 4 square. 5 square is 25 and 4 square is 16, so 9. Can I say R is square root of 9? That is 3. 3 centimeters. Always remember to write the units. Okay, units are important. Whether it's centimeters or meters, carry those respective units because you are giving a length. Radius is a length. So length should have a unit. So don't forget that. Just don't leave R equal to 3 because radius is a length that should be, because the length is given here in centimeters. So you must indicate that the radius of this circle is 3 centimeters. Okay, good. So these type of problems can be asked. Okay, so it's very simple. We need to know that the tangent and the radius makes 90 degrees and that forms a right angle triangle. Just apply Pythagoras. Okay, let's see another one. This is little more understanding and we need to apply more knowledge for these type of problems. Okay, let's see. Two concentric circles. What are concentric circles? The circles which has same center, right? Of radii 5 centimeter and 3 centimeters. So that means I have two circles. Okay, let's say this is the radius. I have, okay, I'll say this is the radius. Okay, this is 3 centimeter radius, and let's say I have another concentric circle which is 5 centimeters. So that means this radius is 3 centimeter and this radius is 5 centimeter. Understood? This is concentric circles, right? 3 centimeter radius and 5 centimeter. Find the length of the chord of the larger circle which touches the smaller circle. Okay. So the chord which touches the smaller circle at one point, right? So let's say I am drawing this. A chord means which divides the circle into two parts, and that has to touch the smaller circle. So this is the chord. Let's say AB is the chord. So for a bigger circle, that is a chord, and that is touching the smaller circle at one point. So can I say that's a tangent? AB is a chord for a bigger circle, and also AB is a tangent to the smaller circle. Can I say that? Right? So O. Now if I draw this, OA is the radius, and also OB is the radius. So what is OA? The bigger circle radius. So OA and OB, right? So OA equal to OB equal to 5 centimeters, the radius of the bigger circle. Now, if I draw a perpendicular here, we know that the tangent with the radius makes 90 degrees. So this is 90 degrees. This side 90, this side 90 degrees. Now, what is the length of the chord? So what is this length? Let's say it is touching at point C, right? So what is OC? OC is nothing but your 3 centimeters, right? The smaller circle radius. Now, let's separate that out, right? Let's separate this triangle together. Then we can easily solve this, right? So AB is the chord of the bigger circle and it is touching, and the AB is also a tangent to the smaller circle. And this length is 3 and this length is 5. This length is 5. So this is O. So can I say these two are right angle triangles? Delta OAC and delta OBC are right angle triangles. Do you agree? These two are right angle triangles. So in a right angle triangle, I know two sides, the other side I can find, right? So let's apply from the first triangle, delta OAC. As per Pythagoras theorem, what is the hypotenuse here? The hypotenuse is OA. So OA square equal to OC square plus AC square. Can I say that? AC, I don't know. I'll find that. Then what is OA? OA is 5. So 5 square equal to OC is 3. So 3 square plus AC square. Then AC square becomes 25 minus 9, which is 16. So AC square is 16. Then I can say AC is 4. Right? AC is 4 centimeters. AC and CB both are equal, right? Because it is touching the circle at midpoint basically, right? If AC is 4, then BC is also 4. Or you can apply Pythagoras, you'll get the same value in the triangle OBC, right? So we can say AC equal to BC, that equal to 4 centimeter. Then what is AB? AB is AC plus BC, right? The length of the chord. AB is AC plus BC. So what is AC? 4 and BC is 4. Therefore, I can say the length of the chord AB is 8 centimeters. Understood? So that equal to length of chord. See, here, don't get confused when they talk about concentric circles, right? First, understand the problem. It is still applying tangent properties. Okay. So two concentric circles of radii 3 and 5. So I draw the concentric circles, two circles with same center as O, 3 centimeter and 5 centimeter. Okay. Find the length of the chord of the larger circle, which touches the smaller circle. So the hint here is for larger circle, AB is the chord, and for smaller circle, AB is a tangent which is touching at point C. Understood? Now, if we join OA and OB, that is a radius of a bigger circle. If I join OC, that is the radius of a smaller circle. I just draw the triangle separately from the Pythagoras theorem. I can see that OAC and OBC both are right angle triangles. And from that Pythagoras theorem, we can find the AC as 4. AC and BC both are equal. So it is 8 centimeters. Okay. So that's how we can solve the problems by applying the knowledge that we have gained. So that's all for today's session. So I hope you all understood the topic, and I'll see you next time. If you have any doubts, please contact me using my Urban Pro profile. Thank you.